All right, guys, good morning. I am going to go through a couple of these problems with you. This is something I created just to kind of get your mind in the right frame. So these are questions that could look similar, but I kind of created these just to give you a little help. Let me see if I can move this up a little with just looking at the problem properly. So Billy solves the equation. Now, whenever you see this question, I really have been telling you this whole unit. Every time they tell you somebody solves an equation, forgive me, there's a gardeners here, so it's going to be loud with the audio, but whenever someone says solve this equation, I want you to solve it first. I want you to write down the equation and solve it on your own and get your answer first. So you have a frame of mind of what the answer looks like. But then as you look at Billy Self's equation, his work is shown below. And now when they do their work, they do it maybe a little bit different than yours, but not much. Step 2 is incorrect. Enter the correct equation for step 2. You can't see that part there. It's hidden. But step 2, okay? So as I look at this, let me move this up here too. Step 2 is incorrect. So let's look at this equation, and if we were going to solve this, we were going to have to, first of all, they did like terms. Make sure you understand that. 18 minus 5 is going to be 13. So that's correct. They said step 2 is wrong. Step 1 is correct. 7 and 5 is 12. So make sure you understand like terms first. And when you get to this point, you should have no issues handling business here. Letters to the left, constants to the right. So, but as you look at this, you can kind of see where their mistake is. All right, we're supposed to add 2x to this side, right? When we move it over, and then you would get 10x. What did they do? They subtracted 2x and they got 6x. So you have to write the proper step. That's what it says. So instead of having 6x, you could put 10x. Let me use my stylus. 10x equals 12. And that's what that step would look like. They're not looking for any answer. Do they want a final answer? No, it says enter the correct equation for step 2. Okay? So make sure you get that idea. Let me clear my screen. We're going to move on. We're going to go kind of quick here. I want to make sure you have enough time to do your benchmark today. All right, looking at this question, Joey is solving the equation 3x plus 1. Let me just move this stuff around. It's annoying me. Joey is solving the equation 3x plus 1 minus 5 equals 3x minus 2. Okay? Now, when solving this equation, you must have to... All right, so as you're looking at this, make sure you understand that they have the work shown again. And what did I say? When you do the work, I would like you to do the problem. Why don't you go do the problem yourself? Not right now, but like if you were taking the benchmark, then look through each step, okay? As you're looking through each step, you'll start to get an idea of what's going on, and then look at your answers, of course. So when you look at your steps, this step jumps out at me big time. When I see that step, I know same same variables, same constants. We've been doing blockets on this forever. That's why I kept doing the blockets, to make sure you got that in your head. When they're the same, when both sides are the same, you know this. We're going to, what happened to my pen? There we go. We're going to call it infinite. Okay, infinitely many solutions. All right, let's go. Let's keep it going. So now, I'm not going to do this problem at all. I'm just going to read it to you guys. Mr. M's pool, we've seen this one before, right? It's 60 degrees, and it is what? It is decreasing. So when you're setting up equations, remember you're setting up equations like this, y equals, and if it's decreasing, it'll be a negative slope, all right? You know how to handle this stuff, okay? And then you would set up the slope as well, or this would be plus 62.2 with a negative 1.2x, okay? And you plug it in. You got this. This stuff is easy. We've been practicing this forever. You guys are going to be just fine. All right, next one. All right, this one's a little tricky just on that way it looks. We did a lot of review on this yesterday. We talked about graphs and how they're going to look when they are, come on, my lovely, there we go. Okay, so after how many seconds will both runners be at the same distance? All right, well, the distance is here and the time is here. It says after how many seconds. Make sure you read the problem. Read what it's asking, all right? Now, this one's kind of tough. As you see, it is going to connect, but what time frame? And if you look at your graph, you can see it's going one. This is 1, 2, 3, 4. It's not going by twos, guys. It's just being labeled as twos. So this is 9. Do they touch at 9? No. How many seconds would it be? It would be one more second. They would touch at 10 right here, okay? and it's not asking the distance, but if it did, it would be 50. So the actual point is 10, 50. They don't care about the point. They care about the x value. How many seconds? Make sure you read the question clearly. All right. Now, this one's a little different. This is towards the end, but this is just an easy endurance problem is what I call it. Why do I call it an endurance problem? Is because you have to solve all of these and see which one's which. So let's just do one real quick. If I did this, I would get 3x minus 15, okay? 3x plus 10. And when I notice this right away, I notice that I have the same variables, different constants. Same variables, different constants, okay? What about here? Same variables, different constants, okay? The only way it's infinite is if they'd be completely the same, okay? When I have different variables, that's one solution, okay? And then there's no equal sign here. It should be an equal sign there. Different variables, one solution. So on this one, so happens that there's no infinite solutions, but that doesn't mean it's going to be the way on the test. Do the best you can on that one. And then this one, I did a lot of this writing, and I'm just going to have fun with this. You're going to see this question, and I need you to calm down. Anytime you see these questions on the SBAC, they love these types of questions where they give you all this writing. And of course, I want you to read it, but I don't want you to get lost in it, all right? I don't want you to get lost in this at all, okay? You do want to read these bottom parts when you're solving problems, but ultimately, what's the main thing? Can you get through and look at this and know what to do? And I know I have confidence in almost all of you can handle this. You look at that and you know what to do. You're going to set this equal to that. So when you see this again, you see all this writing, look at where the equation's at. And then go ahead and break that down on your paper and show all that work. You got this, okay? You got this. Now, okay, last one here real quick. They're going to show you steps. Follow the steps again. Try to solve the equation if you can with the calculator for sure, using fractions on your calculator. But as you're going through this, you'll notice different things. Again, when I look at this, I see same variables, different slopes, or same different constants. So just make sure you understand the ideas behind the no solutions, the infinite solutions. Those ideas aren't going to go away. You need to remember those, okay? So when I said that, let's see again, understanding, where is this one? This idea, understanding the one solution, no solutions, infinite solutions. All right, guys, best of luck. I know that was fast, but just a little quick warm up for you guys before the benchmark. Good luck.